15.1, we're going to learn how to calculate the concentrations of the solutions in two units. One is gram per dm cube, one is mole per dm cube. So first have a look of the three solutions right here, okay? So they're blue in color, most likely they have copper 2 sulfate, okay? They have copper 2 ion in it. So you can see that the intensity of the blue color is increasing from the left to the right. So we'll assume that on the right hand side they have more copper 2 sulfate, more copper 2 ions in it. So if we look at the other diagrams down below here, you can see that, okay, on the right hand side you got more blue dots, okay, together, okay, grouped together, okay, on the right hand side. While on the left hand side you will see that, okay, we got fewer blue dots right there. So we will say that the one on the right hand side will be more concentrated than the one on the left hand side. If we just move the square right there, you can find that, okay, these two squares have the same size. So if we move like that, so you can see that maybe on the right hand side, okay, this particular square, this unit area, okay, this volume with more blue dots in it, more copper 2 ion in it, but the one on the left hand side with less copper 2 ions in it. So we'll say that the one on the right hand side, this one is concentrated, while the one on the right hand side, okay, will be relatively dilute, okay, than the one on the right hand side. Okay, so basically when we consider concentrations, okay, when we are studying junior form, okay, we'll consider things like gram per dm cube, gram per volume, is that right? Gram per volume. But now we know that, okay, even the particles, okay, or the substance have the same gram, the number of particles inside may vary because they have different molar mass. Say for example, when we have like sodium and also when we have like hydrogen, okay, then if both of them they have 10 gram, we'll know that the number of mole of them will be different. So therefore, okay, in right now, okay, we'll learn that, okay, we are not using gram per volume, okay, to consider about the concentration of the solutions. Instead, we have to convert the gram into mole. So therefore, the new unit that we'll learn will be mole over volume. Okay, so have a look of our concentration and molar concentration. The traditional one that we use is concentration, which is mass over volume, that is gram per dm cube. Okay, later on we'll talk about dm cube. What is that? Actually, it's similar to cm cube, but just in a larger volume only. So the new concept that we have learned today is molar concentration. More commonly, we call that molarity. Okay, molar concentrations or molarity. So the molarity of a solutions, we are having number of mole over volume. Okay, so we convert the gram, okay, into number of mole, and then again we convert we over it, okay, with the volume values. Okay, so we'll say that per unit volume. So by doing this, we'll say that per unit volume, how many number of mole of solute, okay, we have in that area. Okay, so the higher molarity, the more concentrate it will be. So what is dm cube then? Okay, so actually dm cube means 1 dm cube means 10 cm. Okay, so if we have 1 dm equals to 10 cm, then 1 dm cube means that, okay, with 10 cm, do it 3 times. Okay, by doing that, we can find that it will equals to 1000 cm cube. Okay, 1000 cm cube. So basically, we have to get used to how to convert cm cube into dm cube, okay, in this chapter. So furthermore, okay, we want to know about the interconversions, okay, for these two concepts. Okay, concentrations and molarities. Okay, they are interrelated to each other, but do we have any equations to show, okay, the relationship between them? So, okay, we can have a look of this. So if we have a concentration equals to mass over volume, so what we need to do is convert the mass into number of mole, right? So if we convert mass into number of mole, we need molar mass to help. So I can do this one, okay, to the both side. Okay, so we'll find that mass over molar mass. Then we can do this, okay, we can convert this into number of mole. So we'll find number of mole on the top and then volume below. Okay, and then on the other side we have concentration over molar mass. Is that right? So number of mole right now over volume, we can then convert this one into molarity, the newly learned terms. Okay, number of mole over volume. So this one will become molarity, and the molar mass can go to this side. So eventually, okay, we'll have an equation like this: concentration equals to molarity times molar mass. Okay, so for your convenience, remember concentration equals to M times mm. Okay, so this is the equation that I want you to remember. Concentration equals to M times mm. Okay, so now I have a quick practice on the conversions between dm cube and cm cube. Okay, so basically if you have 250 cm cube, normally the values, okay, that you have the cm cube will be larger. That means when you have 250 cm cube, okay, what you need to do is divide it by 1000, so it will become 0.25 dm cube. Okay, and then when you have 2.3 dm cube, you need to convert it into cm cube. Okay, then you have to times 1000. Okay, so this one will become 2300. So between dm cube and cm cube, actually when you go to dm cube, from dm cube to cm cube, you multiply by 1000. When you go to the other side, it will be divided by 1000. So for this one, okay, divided by 1000, and you got 0.035 dm cube. And then the last one will be times 1000, and you got 300 cm cube. So basically, okay, you can see that, okay, if you are in the format of dm cube, okay, normally dm cube values, okay, will be relatively smaller than the cm cube. You can see that the cm cube, the values, okay, is larger. Okay, so this can also help you to cross check, okay, if you have more sense, okay, on the cm cube and dm cube. Okay, so basically, okay, you can use this one to help you to do the conversion. So to modify the three paths diagram that we have learned in chapter 12. Okay, so remember long ago we have just focused on the one on the right hand side. When you got mass divided by molar mass, you got number of mole, and for number of mole compound you can divide it by n, okay, to find out individual atoms and ions number of mole in it. If you multiply by L, okay, you can find a particular number of particles in a compound. Okay, remember this L, okay, the value is 6.02 times 10 to the 23 power. Okay, so you can convert number of mole into number of particle like this way. Today, okay, what we're doing, okay, is the one on the left hand side. When you got number of mole, you divide it by the volumes. Okay, remember the volume that we are talking about, it should be in the unit of dm cube. Okay, then you got molarity. Molarity, okay, we'll use the unit mole per dm cube to represent mole per dm cube. Sometimes, okay, people, they may use M, capital letter M. Remember, okay, it should be a capital letter M like this way, okay, not like this. This one is not acceptable. This one, okay, okay. So capital letter M, molar, okay, we pronounce this one as molar. So we can call divided the number of mole by dm cube, and then you got the molar volume, okay, molar concentrations for that. Again, okay, you can multiply this one by n to find the molarity of the ends. Okay, later on you will see a little bit more. Or we can use the new equation M times mm to find the concentration, which is gram per dm cube right here. So the other way to calculate concentration, you can mass over volume to find this one as well. Okay, so in the following videos, okay, I'll use this diagram quite often. Okay, so our next video we'll have more examples to show you how to do the calculation. We don't have summary for this videos because this is the summary already. Okay, so that's all. Bye bye.